Hi everyone, I'm Maria Cinta Francesca Siramin, a senior BS Physics student at the University of the Philippines Baguio, and a research fellow at the Machine Intelligence and Neural Dynamics Laboratory or MINDLab. My thesis is titled Quantifying White Matter Hyperintensities or WMH in Neuroimaging, a case theoretic enhancement of Fazekas grading in dementia. Essentially, my thesis is about looking at bright spots or confluences in brain MRI scans called white matter hyperintensities. These are biomarkers of aging, dementia, and cognitive decline. So, as of now, radiologists rely on a subjective scale called Fazekas, which was established by Austrian neurologist Franz Fazekas in 1987. I've always been fascinated by the intersection of physics and medicine. We were lucky enough to have a sit-down discussion with expert radiologists from UP-PGH, which raised their concern. By creating a tool that quantifies what a doctor sees, we're able to create a more objective system that is consistent, faster, and backed by heavy mathematical and physical data rather than just clinical visualization. I don't see this as a problem, but I see this as an opportunity to improve the Fazekas scale. So to solve this subjectivity, I'll be using KS metrics to measure the physical complexity of the lesions and apply data learning to automate the grading process. The usefulness is twofold. First, it provides a physics-based metric for brain health, meaning we can track how a disease progresses with high precision. Second, is an automated system that can be utilized by clinicians, especially in high-volume hospitals like UP-PGH, where every minute saved in diagnosis counts. Aside from the technical hurdles, the most challenging part was the wait for the ethics committee approval. It took me about 5 months. This means that you have to go through a rigorous ethical standard to be able to touch one single scan. It was a lesson in patience and the importance of data privacy in research. Plus, once the approval finally came, it was a massive sprint in starting the data pre-processing and labeling. The moment where the physics matched the medicine. Seeing a high fractal dimension score perfectly correlate with a severe Fazekas grade is absolutely satisfying. It's like finding a secret mathematical and physical language that the brain uses to describe its own health. Without a doubt, also the collaboration with expert radiologists at UP-PGH. It's one thing to see the code on a screen, but it's another thing entirely to see how that code can support world-class doctors at a clinical setting. Ultimately, my goal in this research is to bridge the gap between high-level physics and daily clinical practice. The study uses chaos physics to provide an objective basis to the traditionally subjective Fazekas scale, and then apply deep learning to automate that insight into clinical use. Thank you so much for having me.